So let's work on our notes for today. Okay? The majority of your assignment you already know how to do because it's based on what we learned yesterday. I'm actually adding one more thing today, and that's what today's notes are on. Okay? Pascal's triangle. That's what we're talking about today. Pascal's triangle has a lot of uses. Most popular is binomial expansion, which is what we're doing today. Okay? But I would like you to know that I use Pascal's triangle in my graduate level classes when we were talking about binomial expansion. I thought that was kind of cool. It's not just one level of math that this can be used for. It's multiple levels of math. Okay? So, have you ever seen Pascal's triangle before? Okay. I'm just going to draw it for you. I want you to draw it in your notebook, please. It's not a pyramid scheme. It's just a pyramid. Do you begin to see any patterns? Yes or no? So what should this line start with? A 1. What should be next? What should it end with? A 1. And what's next? Those are the most common patterns that people can see. Okay? Do you have any idea what number this is? It's 15. Where did you get that 15? Okay, so that's one way that you can get it. All right? Here's another way. What if I look at this diagonal? What's happening in this diagonal right here? Is it? So it added 2, added 3, added 4, added 5. You see that pattern? How did they get this 15? What was the first way they told me? Look, the 2 numbers right above it. Is that true for every number on this triangle? What about 6? 3 and 3? What about 5? 1 and 4? You see that? So there's multiple patterns in this triangle, aren't there? This is 20. This is 15, right? So that's Pascal's triangle. The way we use it for binomial expansion is like this. This top row, this very top row, is A plus B to the 0. This second row right here is A plus B to the first. This third row right here is A plus B to the second. This fourth row right here, A plus B to the... Oh, good. You're seeing the pattern. A plus B to the fourth. A plus B to the fifth. A plus B to the sixth. How many rows of this triangle could we write? However many we wanted, right? Because we know the patterns now, right? We know it always starts with 1 and ends with 1. We know this diagonal is increasing by 1. We know this is adding 2, then 3, then 4, then 5. But even easier than all of that, I know that each number is a sum of the 2 right above it, isn't it? So I could complete, I would say the whole triangle. We don't have time for that. Okay? But I could go to whatever row I needed to, couldn't I? Okay? So here's how we use Pascal's triangle. All right? Let me do this first for you. A, well, I don't actually want to use A. Ignore that, please. X plus 2 to the fifth. What does x plus 2 to the 5th mean? Doesn't it mean x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2? Isn't that what it means? Yes or no? Okay. So that means I'd have to distribute to these two, right, and get an answer, and multiply that by x plus 2, and multiply that by x plus 2, and multiply that by x plus 2, right? Ugh. How many places are there to make mistake in that? Several. Quite a few. Okay? So wouldn't it be nice if there was an easier way? Well, there is. Okay? We're going to use Pascal's triangle to do binomial expansion. So we're going to go to the row like the problem that we have. The row like the problem we have is a plus b to the 5th, right? Well, according to a plus b to the 5th, this row is the row I need. 1, 5, 10, 10, 5, 1. Got it? 1, 5, 10, 10, 5, 1. That's the row I need, right? So here's what's cool about, well, one of the many, many things about Pascal's triangle that's cool. Okay? I'm going to do this multiplication in basically one step rather than all those steps I just told you a second ago. Because what happens are these are the coefficients. I need to make sure you understand the variables though. Okay? If I'm saying a plus b to the 5th, and I'm using these as my coefficients, let me show you what my variables do. This one is a to the 5th. This one is a to the 4th. This one is a to the 3rd. And a squared and a. Guess what this one is? B to the 5th. Guess what this one is? B to the 4th, b to the 3rd, b squared, and b. Now, is there really a b here? Is there really an a here? Yeah, it's to the 0, right? So it's just a 1. We don't need it, so we don't write it. But I start with a of whatever exponent I have. So a to the 5th. The next term is 1 less, 1 less, 1 less, 1 less in the exponent. Does that make sense? Then at the end, the b is b to the 5th. And then the previous term is the 4th, and the 3rd, and the 2nd, and the 1st. Does that make sense where that came from? Yes or no? Yes? Kind of? We can go with kind of. Okay? And then I know all these terms are added together. Now, are they always going to be pluses? Well, it depends on what the signs of A and B are when we actually look at the problem. Okay? In this particular problem, we have x plus 2, which we're about to use binomial expansion for. Okay? To actually get the answer to this. Okay? So, here we go. You ready? In this problem, what's A? X. And what's B? 2. So if I say a to the 5th, I'm really saying x to the 5th. Well, can I simplify that at all? It's just x to the 5th. In this next term, I have 5 times a to the 4th, but what's a? X, so I have x to the 4th, and what's b? 2. Can I simplify that? What is 5 times 2? 10 x to the 4th. Okay so far? So in this next term, I have 10 times a to the 3rd, which is x to the 3rd, b squared. So times 2 squared. Does anybody know what 2 squared is? That took way too long. 4 times 10, 40, x to the third. That one's done now, isn't it? Next term, 10 times a to the second, so x to the second, times b to the third, so 2 to the third. What is 2 to the third? Please don't say 6. Thank you for saying 8. Good job. What is 8 times 10? 80 x squared. Next term, 5 times a, which is x, times b to the fourth, which is 2 to the fourth. What's 2 to the fourth? 16 times 5, 80. Last term, b to the fifth, 2 to the fifth. 2 to the fifth? Done. Is that a puzzle? That's just a puzzle. Is it a hard math thing? No, it's just a puzzle. Okay? It's just making sure that you have the right thing in the right place. So can we do one more example? Okay. I'll make it slightly easier and slightly harder. How about that? How is it slightly easier? The exponent is smaller, right? How is it slightly harder? Yeah, I've got multiple things here, don't I? Okay, so using my Pascal's triangle, what are my coefficients? 1, 4, 6, 4, 1. Okay, so 1, 4, 6, 4, and 1. If I start with to the fourth, what goes here? A to the fourth. What goes here? You have to talk louder when the air is on, remember? A to the third. Can I go ahead and do both at one time? Are you guys okay with that? Some people just want me to do one and then the other. I don't care. You tell me. We can just do one. Okay, so a to the fourth, a to the third, a squared, and a. And then start at the back. B to the fourth, b to the third, b squared, and b. You ready? What is a in this problem? 4x. Okay, so I have 4x to the fourth. What is 4x raised to the fourth? I've got to raise both terms to the fourth, don't I? Okay, I need you to settle down, please. What does it mean to raise something to the fourth power? Please. 4 times 4 times 4 times 4, right? 4 times 4 is what? 16 times 4? 64. 64 times 4? 256. Everybody okay? Now I have 4 times 4x to the third times negative 2. That's the 4. That's the A term. That's the B term, right? So let's start in here. What's 4x to the third? What's 4 to the third? 4 times 4? 16 times 4 is 64, right? So I have 64x to the third. That's what this part is right here. 64x to the third. But then I'm going to multiply that by 4. Well, I kind of did that over here, right? 4 times, so I've got 256. But 256 x to the third times negative 2. Negative 512 x to the third. Got it? Yes or no? You have to tell me. Because I wrote it A on accident. Thank you. That was my fault. Sorry, Kim. Everybody okay? Okay. So this next term is 6 times 4x squared times negative 2 squared. Well, what's 4 squared? So this is 16x squared. What is negative 2 squared? Positive 4. So I've got 6 times 16 times 4. You guys all have calculators and you're all staring at me. You can all do it, right? Yeah? What is 6 times 16 times 4? 384. So plus 384 x squared. Okay so far? You have to tell me if you're not. Okay. Now I have 4 times a, which is 4x, times negative 2 to the third power. Well, 4 times 4 is 16, right? So this is 16x. What's negative 2 to the third power? Negative 2 to the third power? Negative 2 times negative 2 is 4. 4 times negative 2? Negative 8. It's negative 8, guys. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2, negative 8, right? So what is 16 times negative 8? Say again, please. Thank you. And then the last term I have is b to the fourth, which is negative 2 to the fourth power. What is negative 2 to the fourth power? Negative 2 times negative 2? Positive 4 times negative 2? Negative 8 times negative 2? Positive 16. What? I only gave you 2, first of all, and I just did one of them. Okay? Any questions?